Hello, everyone. So today we're going to use the information we learned yesterday to prove that things are parallelograms. So when I look at this proof, it's given that PQRS is a quadrilateral, and we know that angle 1 is congruent to angle 2. Well, if angle 1 is congruent to angle 2, angle 1 is this angle right here, and angle 2 is this angle right here. So you can see that they're both on QS, so that's my transversal. And then the other part of those angles, which is PS and QR, are parallel because alternate interior angles congruent, so congruent alternate interior angles implies parallel lines. Now, if I do the same kind of thing with angle 3 and 4, which are also congruent, angle 4 is here, and angle 3 is here. So again, they have the transversal of QS. That's the line that they both share. And the opposite sides are parallel. So that means SR is parallel to PQ. And it's for the same reason. So I can write it in the same step. Now that I know both those pairs are parallel, that means this has to be a parallelogram. Is a parallelogram because it has two sets of parallel sides. So again, we're using our alternate interior angles. So now if we look at number 2, we know that ABCD is a parallelogram. So that's this big one. So if we know ABCD is a parallelogram, and this one I gave you kind of parts of it to help us, we know that opposite sides of a parallelogram are congruent. So what sides would we know are congruent then? Well, we would know that AB is congruent to DC. We also know that AD is congruent to BC because those are opposite sides of our parallelogram. We know that angle A is congruent to angle C, and the reason why we know that is opposite angles of a parallelogram are congruent. So then they're now telling me that we know that DAE is congruent to BCF. And why would we know that DAE, so this purple triangle, actually let's not do that purple because I've done everything else in purple. DAE is congruent to BCF. Well, we knew these angles were congruent, and I knew that AD was congruent to BC, and it's given that AE is congruent to CF. So that means those triangles are congruent by side, angle, side. So now, why is DE congruent to FB? Well, those are parts of our congruent triangles, so that means that CP, CTC, corresponding parts of congruent triangles are congruent. Next, we're going to say that DC minus CF equals AB minus AE. So what am I doing there? I'm subtracting. So that's subtraction. And then if we look, DC minus FC is DF, and AB minus EB is EB. So that's our substitution. And then if we look at this shape here in the middle, we know that EB is congruent to DF. We know that DE is congruent to FB. Therefore, we know that's a parallelogram because opposite sides are congruent. Therefore, it's a parallelogram. So that's the end of our video today. Tomorrow in class, I'm going to expect you to do some proofs. If you have any questions, please bring them to class tomorrow.